Hi there. So this review is about looking at position time graphs and seeing how to convert that into a velocity time graph. This is a good review if you want to be converting from both, or if you just want a quick refresher on how to read a position time graph. So here we go. So looking at this worksheet here, a dog starts to walk from a position that is 5 meters to the right of its owner, and a graph of the dog's motion is below. So you can even tell right at the beginning of the motion, their initial position is already at 5 meters. That's where it's starting from, not at the origin, like it's telling you there. So let's break it down into each segment. So I'm going to create a little table here. So I'll have my segments. I want to look at the velocity of each segment and then the time frame of each segment. That way when I'm trying to make my velocity time graph, I have my velocities and I have the times that it was going that velocity. So let's break it down into the segments. We got A, B, C, D, E, F, G. Okay, let's look at the first one. Let's label that with the red here. So this very first one here, let's calculate the velocity for it. Well, our final position is 8. At the very end of segment A, it's at a position of 8 meters, and its initial position was 5 meters like we said. So if we're going to find the displacement there, 8 minus 5, our final position minus our initial position, that's what's at the top of our velocity equation there. Underneath is just our change in time. We started at a time of 0, we ended at a time of 2. 2 minus 0 is just 2. And if we do our math here, we get 3 divided by 2, or positive 1.5. We don't have units on there yet, but when I throw that in, we know that our velocity is 1.5 meters per second. And let's throw that in our table now. So, just looking at that table, our velocity was positive 1.5 meters per second over those first 2 seconds. And that kind of goes with just our slopes. If we're looking at the slope of that line, we know it's going to be a positive slope because it's pointing upwards. Okay? Let's look at the next section. So that's our yellow one, B here. Let's try to find the velocity of that one. This one's a little easier. The time for this one is from 2 until 4 seconds. But just looking at it, it's a flat slope. There's a 0 slope. At the beginning of the motion, at 2 seconds, it's at a position of 8, and at the end of the motion, it's still at 8. So our velocity there, we just know is 0. It's flat. Let's look at C now. If you want to find the velocity of C, we're going to do the same approach we did to A. We just got to be careful when we're ordering for the top of our velocity equation that we make sure we have the order correctly, right? So we want to have our final position minus our initial position. Our final position here at 7 seconds, you can see is right back at the origin at 0. And then our initial position was 8. So it's 0 minus 8. You can remember to do it this way, final minus initial, or you can just look at it. You know that you started at 8 and you went back down to 0. That's a displacement of negative 8. And our time was from 4 until 7 seconds, 3 seconds. And we calculate that, we get a negative 2.67 meters per second. And we know that one's going to be negative. We could do it from the math, we know it's negative, or we can just look that the slope is down, we know it's going to be a negative slope moving to the left. Okay, D is just like B. This one's easy again. From 7 to 9 seconds, we've got a flat slope. It stays at the origin, it stays at 0. We just got a 0 velocity. So let's look at E now. This one's a negative slope again. Just from looking at it, we can tell it's going to be negative, but it's not going to be quite as big as section C because look, it's not as steep. So for this one, we just go down one spot. So our velocity here is just negative 0.5 meters per second. And we throw that back in our table. Section F, again, this one has to be negative as well, but it's going to be a little steeper, so we probably have a greater amount, like negative 2 point something, I'm not sure. So if we do the math there for section F here, our final position is negative 6, our initial position is negative 1, so we went down 5 over those 2 seconds. Again, you can do that from the math, or you can just look at it. You started at negative 1, you ended up at negative 6, that means you went down 5. So for there, our velocity was negative 2.5 meters per second from 11 until 13. And then finally for G, what do you think our velocity is going to be? Is it going to be positive or negative? Well, it's sloping upwards, so I think we're going to switch back to positive. Let's see if the math checks out. Final position was -4, initial was -6, so we actually went up 2 spaces there over 2 seconds. So for there, our velocity was +1 meters per second. So once we have this table set up, now we can convert this position time graph into a velocity time graph. So I just threw the table over here, and now we're going to make our graph. So let's set it up this way. So remember, let's have our time in the middle here, because we're going to have some negative velocities, so we can't just set it up without having room underneath. So we've got our velocity as our y-axis. Let's set our points. I made those thick lines, those are every 5 seconds. Okay, let's look at our first section now. For our first section, from 0 seconds until 2 seconds, we were going at 1.5 meters per second. So that line is just going to be flat. We were going at that velocity for 1.5 meters per second for 2 seconds. Let's look at section B then. For that one, remember the velocity was 0. On the position time graph, it was a flat line. It's also going to be a flat line here, but what's important is that it's right on that timeline there, right at 0. That shows us that the velocity was 0 there. It wasn't moving at all. The tricky thing here is, this isn't really a real-life situation. We talk about a dog, a guy walking his dog, whatever, but the graphs wouldn't look like this in real life. They'd have curves to show an acceleration. You can't go immediately from 1.5 meters per second to 0 in an instant. But that's what we kind of did here at 2 seconds. So what we do is add that dotted line to show that those lines are actually connected. It's not really accurate in real life, you can't do that, but that's how we connect it. Section C, down here at -2.67 meters per second, and again, let's connect that, and so on and so forth. Let's just finish this off. And then, just to label it, we'll add our segments there. So, go back through the video, take a look at the position time graph, take a look at the velocity time graph, understand how to go back and forth, and for the test you might not have to do this completely, but knowing how to do everything will help definitely for the test.